Hi everyone, in this session I'll introduce SecureMR, a new framework from Pico that lets you build AI-powered mixed reality apps directly on your headset. Normally, headsets don't allow direct access to camera images because of privacy concerns. SecureMR solves this by running your machine learning models and rendering logic inside a secured environment on the device. That means your app never touches the raw images, but you still get all the power of on-device AI for things like object detection, face tracking, pose estimation. SecureMR uses three key building blocks: tensors, operators, and pipelines, which we'll explore more in the next few slides. Here you can see two demos. One is UFO, and third is the MNIST demo, which recognizes handwritten digits from the video feed and displays the predicted number instantly. These are just starting points. You can plug in your own models, GLTF assets, rendering logic to create your own interactive spatial AI experiences. Now, I would like to talk about Tensor. Tensor is basically any piece of data your app wants to process, like camera images, 3D points, model outputs. The key difference from normal machine learning tensors is that data never leaves the secure service. Your app only gets a handle that points to the data, not the data itself. You can create tensors, write into them, but you can't read them back. That's how secure MR products protects your user privacy. Each tensor has four basic attributes: shape, number of channels, data type, usage, like matrix, scalar, color, or timestamp. Next is the operator, which is like the function or processing unit of secure MR. Operators take input tensors, perform some operation, and then write results into the output tensor. For example, one operator might capture camera images, another might run your machine learning model on the NPU, and another could render the result into 3D space. You can connect them using set operand for inputs and set result for outputs. That's how data flows securely through the pipeline. The third concept is pipeline. This is where everything connects. You can think of a pipeline as a graph of operations. Each operator in the pipeline runs one after another, passing data through the tensors along the way. When you call execute, SecureMR runs the whole chain inside its secure runtime. You can also schedule pipelines with dependencies or conditions, like run this one after another finishes, or only if a tensor is true. Pipeline lets you combine model inference, data processing, and rendering into one secure workflow. Now let's talk about global tensors. By default, tensors are local. They exist only inside one pipeline. But what if you want to share data between two pipelines? For example, one doing face detection and another one handling rendering. That's where global tensor comes in. They act as shared memory between pipelines while still staying inside the secure environment. So you can write results into a global tensor in one pipeline and read them from another without ever exposing the data to your app. Now, finally, let's understand what placeholder is. Placeholders basically connect local and global tensors. For safety, operators can't directly use global tensors. Instead, we create placeholders. Local tensor handles that behavior like pointers. When you submit a pipeline, map each placeholder to a global tensor for that run. This is powerful because it means you can reuse the same pipeline multiple times, each time mapping it to different data inputs. That's how SecureMR lets you manage real-time data flow between multiple secure pipelines.